Good evening. Hello, everyone. Welcome. How's the pizza? Go ahead and grab a drink, grab some pizza. The program's right ready to start. Hey, I'm Steve Sarner, VP Marketing here at TAG. We're thrilled to have Spark back, the Spark Meetup back here at TAG again. Thanks so much for coming out here to space. For those of you who are not familiar with TAG, we're one of the world's largest social networks, over 300 million members worldwide. We've been profitable since 2008.
And the release is being currently packaged up, and you'll see it and be able to download and run it at 091 by within like 24 or 48 hours now. And that was a new release manager, TD, who is also the lead on Spark Streaming. So thanks to TD, who's not here tonight. He's busy working on actually packaging up the release. This is an evolution in the way we do maintenance releases. So 091 is a maintenance release. It's the last number, the minor number is kind of incremented there, or the bug fix number. And we've moved as a community towards a strong focus on making maintenance releases just that, so only bug fixes. So we really strongly encourage, unlike other maintenance releases in the past, where maybe there were some features that slipped in there, that made them questionable as to whether it was time to upgrade or not. We encourage everybody who's running 090 to actually upgrade to 091 for all the bug fixes and performance improvements. Besides that, the Spark Summit, which is scheduled for the end of June 31st, 30th, whatever the last day of June is, and the first 2 days of July. The application process ends on Friday. So that's in 3 days or 4 days, whatever it is. And you need to submit your talk abstracts by Friday. The program committee will be voting on them for the week following that, and then we'll release the agenda as soon as possible so you can all buy tickets and know what you're coming to see. So please submit your talks for the Spark Summit by Friday. And then the next meetup is going to be in the South Bay. We've been working towards more than one meetup a month in the Bay Area, alternating between South Bay and San Francisco. The next one's going to be at Cisco on the 23rd of this month. Right, Scott? Yeah. So we'll see you in the South Bay, those of you that are from there or willing to take the trek. Otherwise, if you've noticed, and the people who are on streaming now, we've been putting everything on YouTube and streaming everything for the last 2 or 3 meetups. We're going to continue doing that indefinitely. Speaking of meetups, you probably saw, some of you probably saw my email or some of our emails to the users list about new meetups in cities that are outside the Bay Area. We've got a big pouring forth of excitement and champions stepping up in other cities like New York, London, Montreal, Vancouver, Chicago, and like 6 others. Not all of them have run a meetup yet, but if you know people in those cities that are using Spark, please have them either email me or respond to that thread on the mailing list. We need people in these cities as we're bootstrapping those cities to start running meetups of their own. I think that's all of the news. And now I'm excited to present or introduce Michael Armburst, who is a PhD student in the Berkeley AMP lab at the same time as Matei, myself, and T and Reynolds and a lot of the other folks that you've seen coming out of Berkeley, working on core projects in the community. Michael's been leading the effort to build essentially the next generation of SQL on top of the Spark platform, and he's here to tell you all of the details about that.
So like Andy said, my name is Michael Armburst. I'm here to tell you about Spark SQL and this new optimizer that we built in order to enable Spark SQL Catalyst. So just to kind of give myself a feeling for the room, who here is like pretty familiar with Spark? Who's written Spark programs? And, okay, excellent. Who here has used Apache Hive? Oh yeah, okay, awesome. Who here is a Scala programmer? Oh, this is great. I love this room. Okay. Good, you guys are going to understand these slides. So, just a high-level overview. So, Catalyst is an optimizer framework. So, it's actually implementation agnostic, and it's a general way for working with relational trees. So, think programs that are going to execute SQL. And so, basically, what we did was we built this, this implementation agnostic framework, and then using it, we built Spark SQL. So, I'm going to break this talk down into a couple of parts. I'm going to start with kind of just a high-level overview of what Spark SQL is and the features. Then I'm going to dive down into the API and actually show you some code samples about how you can use Spark SQL and how Spark SQL allows you to blur the lines between RDDs and relational operators. And then finally, I'm going to get actually a little bit into the optimizer for those of you who might be interested in contributing to Spark SQL, just to kind of show you some of the power that's underneath the hood here. So, a big question here is, what does Spark SQL mean and how does this relate to Shark? So Spark SQL is a basically from-scratch rewrite that leverages the greatest parts of Shark. So for those of you who aren't familiar, Shark is another project that came out of the AMP lab that allows you to run Apache Hive queries on top of Spark, sometimes 100x faster than Hive could. And so kind of what Catalyst is doing here, what Spark SQL is doing, is we took all of the Hive interoperability code that allows us to kind of load data, reuse your existing SERDs, and we also took their incredibly fast in-memory columnar representation, and we also leveraged the fact that they spent years making Spark kind of a really great hardened execution engine. And then in addition to that, we kind of threw out the Hive optimizer, and we instead have our own RDD-aware optimizer that doesn't have a lot of the baggage that MapReduce kind of brings along with it. We rewrote the execution engine, and we really kind of tried to work on integrating it with the other language features that Spark has. And I'll kind of get into those details later in the talk. And by the way, this should be pretty informal, so if you guys have questions, please just raise your hand. So, kind of one of the big things that we realized was important, because a lot of our target users here already have Hive deployments, already have data stored in Hive, is Hive compatibility. And so Spark SQL interfaces very nicely with both data and code that exist in the Hive ecosystem. So this means you can write Spark SQL queries in HiveQL. We have a catalog interface that allows you to read things that are stored in the metastore, so you can kind of leverage that existing investment there. In addition to that, we have a table scan operator that supports reading from all of the different types of Hive SERDs, so you don't have to do any ETL or translate any of your existing Hive data. And finally, you can actually even bring custom UDFs or the existing Hive UDFs that you're already using and use them in Spark SQL. There's a little bit of a performance penalty for doing that over writing native things, because we have to translate types, but everything will work. One other thing I'll say is that right now the Hive support is actually implemented as an optional module. So it comes with Spark, but you have to compile it separately. That is because Hive brings with it an obscene number of dependencies, and we were concerned about breaking existing Spark applications. So if you want Hive, all you have to do is set the Spark Hive flag, and this is all covered in the documentation. And we'll make special releases that include Hive. But just please realize that this is kind of an extra piece which you can add on to Spark SQL. And you can use Spark SQL also without Hive if you don't already have data in that ecosystem. So another thing that we're actually pretty excited about is Spark SQL has native support for Parquet. So for those of you who aren't familiar, Parquet is a columnar disk format. Yeah, so you can read all Hive files through the standard Hive SRDs. We do not natively read ORC files, but you can read them using the Hive SRD that supports that. So the native Parquet support, kind of the nice thing here is you can do this directly with Spark SQL without bringing in the SRDs. This is a kind of a nice way to write data out and preserve the schema. So you can take your existing Spark RDDs, apply a schema to them, write them out, and then bring them back in, preserving all of that schema information. So this is actually something that we're pretty excited about. It allows you to interoperate with data that's stored in Impala, and Twitter is, I guess, a big user of Parquet as well. So I think this is kind of a very interesting up-and-coming file format. And then the nice thing is it gives you a lot of performance benefits. Since it is columnar, when you write a query, if you have a very wide table that has many columns, but you're only actually accessing some of them, Parquet is capable of skipping over reading all of the data that it doesn't need, reading only the columns that are necessary for the query. So now that we've kind of done the high-level overview, how does this fit in the ecosystem, let's dive into some examples of actually using Spark SQL. So kind of for those of you who are familiar with the Spark context, Spark SQL adds a new construct, a SQL context, and all you need to create a SQL context is an existing Spark context configured in your normal way. This just wraps around it and provides the catalog and all of the relational functionality. And all you have to do then is import this into the context of your program, and all of a sudden you have access to all of the implicit conversions and methods that you would use in order to interact with SQL. So once you've set up your SQL context, there's the question of how am I actually going to interact with this data? And so what Spark SQL does is it introduces a new type of RDD. So just in case anybody's not familiar with this, RDDs are Spark's kind of core data abstraction. They're immutable data sets that you can do coarse-grained transformations, think map and reduce and things like that on. But the problem with RDDs is the data inside of them is opaque to Spark. It doesn't know what types of objects are inside of there, and so it can't do optimizations using that extra information. And so what a schema RDD is it has all of the power of a normal RDD with the addition of schema information. So we know the names and types of all of the columns in the data, and with that we're going to be able to do quite a bit of optimization and actually kind of write a lot of the program for you that you used to have to express imperatively. So how do I actually create a schema RDD? How do I turn one of my RDDs into a relation? So I'm going to do all these examples in Scala, but we also have a Java and Python API, which I will touch on at the end of this. So basically, the way you define a schema is you create a Scala case class. So this is just a standard Scala case class. In this case, I'm creating a data type called person. It has two things, a name, which is a string, and an age, which is an integer. And in order to turn something into a schema RDD, all I have to do is take an existing RDD and translate it into an RDD of these case class objects. The case class objects can contain arrays, like lists and other sorts of complex types. They can even be nested, so you can put case classes inside of case classes if you want to have nested data, probably because you're denormalizing or things like that. So in this case, you can see I'm just reading in this text file of people, splitting it by commas, and then I'm converting the data types and creating people. As soon as I have an RDD that's of case classes, importing the SQL context, like we did on the previous slide, actually adds all of these implicit conversions so that RDDs of case classes kind of automatically become schema RDDs. So this allows me to say, register as table, and now this RDD is available inside of SQL as a table called people. So once we've registered our RDD as a table, we can now run SQL queries over it using standard SQL. So what you'll see here is I had my list of people before. Now I want to pull out all of the teenagers and their names. So I can just select where their age is within the desired range, and you get back another RDD. And so I think kind of the really cool thing here, and you can contrast this to kind of the way people would usually interact with Shark, is that the results of SQL queries are also themselves RDDs. So I can go straight into doing .map and other functions on it. If I want to get the values out from the row, I can just index into them. And then you can collect and actually run all of your standard RDD transformations there. But SQL's not the only way that you can interact with Schema RDDs. Another way that we have is this Scala DSL. So in this case, you're actually writing functions that slowly build up what would be a relational query. So this is the exact same query expressed using the DSL for querying. So we take this people Schema RDD, and we can say filter out all of the people who are younger than 10, and then filter out all of the people who are older than 19, and then pull out only their name. And so what's happening here is these expressions here so we have implicit conversions. So for those of you who aren't familiar, this is a Scala symbol. You can think of it like an intern string in Scala. We use these to refer to the names of columns that we're referencing. And then there's an implicit conversion on symbols that anytime you use it in an expression, instead of evaluating that expression, we actually turn this in runtime, we can actually give that to the optimizer, which can then understand how to actually run this query using that expression. So, one of the great things about Spark is that you can actually cache data in memory and do interactive analytics over it. So this is one place we actually leveraged a lot of the investment that went into Sharp. We were able to port the in-memory columnar format from Sharp to run inside of Spark SQL. And the idea here is what we're going to do is we're actually going to take your RDDs, we're going to build up columnar representations of them, which we store in memory. And this has some significant advantages over just calling .cache on an RDD normally. So first of all, we understand the columnar structure. So when you run queries later, you'll use less memory bandwidth because we're only going to scan over the desired columns. And then a huge thing here is because we understood the structure of the data, we know how to efficiently serialize it in a columnar fashion. This means that you're keeping a lot less objects around. And yet we can still do that serialization and deserialization very efficiently. So this means significantly less pressure on the GC, even when you're holding giant amounts of data in memory. So we've tried kind of doing the naive .cache and using this in-memory columnar format, and many queries that would just kind of tip over the GC run very nicely with the columnar in-memory format. And then another thing that we've added is compression. So we have a number of different compression techniques, dictionary encoding, delta encoding. And as it runs, as it materializes these in-memory, your in-memory results, we actually select the best compression scheme for you automatically. And if there is no compression scheme that works particularly well, we actually just skip compression entirely to avoid extra CPU with little benefit. So I promised you that wasn't the only way you could run things. Another thing you can do is you can interact with Parquet files. And like I said, this is kind of a native thing in Spark SQL. So anytime you have a Schema RDD, this is just the collection of people from our last example, you can just call save as Parquet file, and using Scala reflection, it automatically infers the schema of that relation, and is able to save it in Parquet, creating all of the Parquet metadata needed to serialize this information out to disk. The really nice thing here is these are self-describing. So you never need to worry about creating your own format, figuring out how to parse it when it comes back in again. If you use Schema RDDs, what you get back from the Parquet file already has all of the metadata associated with it. So you don't have to worry about splitting and remembering the column names, all the things that you would do if you're writing a CSV file or something like that. And so once we pull back in a Parquet file, you can use this as a Schema RDD. So it can also be registered as a table. So in this case, we just registered this as Parquet file. And as soon as it's registered, you can use it in future queries, just like you would an RDD that we created in memory, kind of programmatically. So another thing that you can do is you can also read data that's stored in Hive. So in this case, you're going to create a slightly different version. So you notice in the first examples, we were working with something called a SQL context. A Hive context just inherits from SQL context and adds extra Hive functionality. So one of the things that it does is now you have access to the metastore. So if you reference tables that are in the metastore, we'll automatically talk to it and get all of the schema information from the metastore and figure out where the data is located and how to deserialize it. But the other thing you can do is, in addition to running standard SQL, you can now use HQL. So for those of you who are familiar with HQL's weird syntax, things like this are now valid. And you can also do DDL commands. So if I want to create tables or load data, all of this is actually just passed back to the Hive execution engine. So we have very good compatibility for running DDL commands, since we just let Hive do what it does best, manage the meta store, and we let Spark run all the DML queries using its much faster execution engine. So, okay, so now we see how you can load data, how you can save data, and how you can load data back in and interact with different things. But why is this important? And I think really kind of one of the key things that Spark SQL gives you is the ability to kind of intermix data. So I talked about blurring the lines between RDDs and relations before. So in this example, what I'm actually doing is I have some data stored in Hive. I have a bunch of users, I have a bunch of events. And using that information, I want to predict what sorts of users might take certain actions. So say, subscribe to a new service, for example. Normally what this would require is writing your own custom Hive code that extracted that data and turned it into an RDD and then running ML over it. In this case, I can just load the training data as a table, and join it and kind of do all of the ETL that SQL is really good for. But then writing machine learning in SQL is kind of difficult. It's possible, but not something I recommend. And so what you can actually do is just drop down into standard Spark here. Create a feature vector out of the things that I pulled out of the Hive table, label those points, and then just run logistic regression. And so basically you're able to leverage the power of MLlib in Spark alongside your existing data that's stored inside of Hive. And another nice thing, since we have the power to do all these things, you don't have to study this slide too closely, but basically what we're able to do is we're able to create data from Hive, take data, and we'll call this Hive table. We're able to take data that's in an existing RDD and call it RDD table, and also load data that's stored in Parquet, and in a single SQL statement, you can join all of these. Because it turns out, once you get into the Catalyst execution engine, it's all just Schema RDDs, so we're able to easily join these different data types. So, I promised you that there was going to be some Java in here as well, for those of you who aren't Scala fans. It turns out you can do all of these things that I talked about today, except for the query DSL, in Java as well. So basically, yes?
When you load Parquet, do you load the whole Parquet file in memory, or do you kind of selectively load it as and when you require it?
That's a really good question. So when you say load Parquet file, like most operations in Spark, that's lazy. All you're doing is creating a logical operation that points to that Parquet file, and then after you write a query over it, we actually optimize down, we push predicates and we push columns down into our actual Parquet table scan, which at that point would figure out what data actually needs to be read. If you took a Parquet file and you call a cache table on it, then it would load the entire thing into memory and you can query it in memory. But it's up to you whether or not you want to immediately materialize that data or whether you want to wait to know more about the structure of the query. So this is basically the exact same example in Java. The difference is, since Java doesn't have case classes, you just create Java beans. So flashback beans or something. But if you create Java beans, sorry, I didn't have a hard time. He actually worked on Java beans. So basically, then all you need to do is give it the class object, and it's able to infer the schema using that information. And of course, we have Python support as well. So basically, in Python, instead of creating case classes, since everything in Python is a dictionary, you can just create dictionaries that have the column names and the data. What we do is we actually look at the first row to infer the data types. We're going to kind of work on that and maybe make that better in future releases, but this is kind of the initial cut at it. This allows you to take your Python RDDs and turn them into Schema RDDs and also query them as well. And you can also read data in from Hive into Python, and all of the other SQL context things are supported in Python as well. Okay, so that was kind of the high-level user overview of how Spark SQL works and how you use it to interact with data and RDDs. Yeah?
You said you can also cache the tables. Mm-hmm. Do you still have this, I mean, is it going to be better to cache tables instead of normal RDDs?
Well, so better is a difficult question. So the question was, you can cache tables. And is it better to cache tables instead of caching RDDs? I would say, in general, it's actually probably more efficient to cache a table than to cache an RDD, and this is because of the schema information. When you cache an RDD, we're basically just using cryo or Java serialization, which is naively writing all of those bytes out to disk. When we have schema information, we can actually shred that data structure, store different columns together, which gives you much better run length encoding. And we actually understand this is an integer, so we can store it in a very efficient integer encoding, which is harder to do with kind of generic Java objects. So, not always the case, but in many cases, it would be better to cache a table than to cache a standard RDD. Yes?
So I also a related question. So basically, we have an existing Spark code which uses normal RDDs, and this schema RDD supports all the operations of normal RDD, right?
Yes, the schema RDD actually inherits from RDD.
So we can just use this Spark SQL without actually writing SQL code, just to add this schema information, and our most of our operations should be or might be right?
Yeah, so one of the questions here was if you're not using any of the SQL stuff and you just want to cache RDDs, can you apply schema to a standard RDD and then use that cache representation? And the answer is yes, you can do that, but I'm going to say one thing. When stuff comes out of a schema RDD, it's been converted into rows. So you're not going to get case class objects back, you're going to get rows back. But it would probably be more efficient to cache them in that way than to just use the standard cache. One thing I will say, this is kind of a wart on the current version of the API. If you call .cache on a schema RDD, it uses the standard RDD caching mechanism. It is only when you call cache table that it uses the special one. That is something that we want to fix in future releases. But that's how it works now. Any other questions before I kind of get into the optimizer? Yeah?
What's the extent of SQL support?
The extent of SQL support. So what I'll say is that the SQL support built into SQL Context is very limited at this point. It's a pretty simple parser that I wrote in a couple of days. If you want more complete SQL support, we support a pretty significant quantity of HiveQL. So if you want the kind of all the things that HiveQL will support, we do quite a bit of that. We don't do buckets and some kind of the more esoteric features, but most of HiveQL is supported. So I mean things like aggregation, things like joins, nested data, all of that stuff is supported in SQL. Yes?
My question is, what's the future of Shark in this program?
That's a great question. So I'm going to talk about this a little bit later, I might as well just say it now. I think it's quite likely that Shark will switch to using Spark SQL as its execution engine. So right now, Spark SQL is missing some things that you would get from Shark. So if you want to run a JDBC server, if you want to use the Shark console where you can just type in SQL commands, those things don't exist in Spark SQL yet. We will be working on a kind of a preview release of Shark, which uses the Spark SQL execution engine, probably coming out in May. So I think kind of the way to look at it is Shark has been a project for years and is actually being used in production in many places. But in terms of moving forward, we are going to be devoting all of our engineering resources to making Spark SQL kind of a much faster platform long term. That said, I started working on it in October, so it's this is the alpha release. Yes?
Are you planning to support custom data types?
I'm sorry, say that
Are you
again.
planning to support custom data types?
That is not on the roadmap right now, but we should talk about what exactly you need for custom data types. So I mean, if it's something where like just nested structures is enough, then we already have that. But we'd have to talk about kind of there's nothing architecturally that would make that super difficult. It's just a question of how are we going to expose that to the user. Any other questions before I get into the optimizer? Okay, so I won't spend too much time on this, but I just kind of want to show you some of the cool things. So kind of in contrast to systems like Hive, one of the differences here is almost everything in Spark SQL is expressed as a rule. A rule is kind of a transformation. It takes one query plan and turns it into another query plan, making a relatively small change. So this is kind of the way the system works. We take a Hive AST or a SQL AST, and it comes in as an unresolved logical plan. And everything after this point is just a tree to the system, and we're just changing these trees over and over again. So all analysis, so saying things like, you gave me this string name, I need to figure out where name is coming from and what its data type is. That's all just rules. Things like optimization, so actually making the query run faster by doing constant folding or things like that. Also expressed as rules. And then the way that we actually go from a logical plan to a physical plan. So we say, you asked me to do this, how am I actually going to execute it? Am I going to create a hash table and join in that way? Am I going to sort it and then do a merge sort? Those sorts of decisions are also expressed as rules. So why is that kind of cool? It's this relatively small concept of tree transformations that we can reuse throughout the system. So almost everything can be expressed as a tree. So logical plans, expressions like A plus B, and then the actual physical operators like scan this table. All expressed as trees, and these phases of transformation prepare a tree for execution. And so the reason we think this is actually pretty cool is it explicitly decouples the phases. So it's very clear to reason about when things are happening in the system, which we think makes it much easier to expand, and also easier to add cool new features like cost-based optimization. That would just be a new phase in the system. I'm going to just go through a couple of examples here, but these rules are concise modular specifications of these tree transformations, and we use a lot of kind of cool Scala features in order to write these very concisely. And the reason why we think it's important for them to be concise is it makes it much easier for the developers of Spark SQL to reason about the correctness and to add new features without possibly executing queries incorrectly. You can see in these 4 lines of code, we're actually doing something called constant folding. So we walk over the entire tree, and anytime we find an expression that can be evaluated statically, so if I say like, where A equals 1 plus 1, there's no need to evaluate 1 plus 1 for every row in the tree, or every row in the table, that would be very expensive. This single rule walks through and finds all examples of that and folds them down into constant statically before we even start executing the query. Another example here, combined filters, which I'll go into in a little more detail. Basically what this does is anytime I have multiple where clauses in a row, instead of doing them one at a time, we can actually collapse those all down into a single expression evaluation. So to just kind of walk through the syntax real quick. What we have here is a logical plan. So you can think of this as a query where we haven't yet figured out how we're going to execute it, but we know what data the user wants to get back. We call this method called transform. This is kind of where all of the magic in Catalyst comes from. And what transform does is it takes a partial function that takes a tree and returns another tree, and it only matches some trees. So in this case, we're only going to find cases where there's a filter on top of another filter. And what we're going to do is we're going to replace this double filter with a single filter where we've ANDed the 2 conditions, and then we just put the child back in where it was. And what Catalyst takes care of is walking this tree, skipping over any nodes where that pattern doesn't apply, and then rewiring the tree back up when you're done. And since everything is immutable and functional, it's actually pretty easy to kind of memorize things about your child and other things that kind of make reasoning about correctness much easier. Another thing that we're actually pretty excited about that this tree structure makes it easier to do is code generation. So this won't be in the alpha release, but it's something we've been working on. Those of you who have tried to do a lot of work on the JVM know that kind of doing interpreted expression evaluation can be very expensive. You've got a lot of virtual function calls, you have a lot of branches based on data type. Really the killer here is you're often allocating objects, even if you're just working with integers or things like that. And these will slow things down due to allocation, but also cause quite a bit of memory usage and GC churn. And it turns out generating custom byte code can actually run this significantly faster. So what you see here, this line here takes so basically we're evaluating A plus A on a table of 1 billion integers. With just kind of standard interpreted evaluation where I'm like, I have an expression that does this and I walk that tree recursively evaluating it. It takes up to 60 seconds. If I reuse objects, I can get it down to somewhere between, I guess it's like 40 seconds. However, if I hand code it so that I'm actually using integers and I'm just saying integer 1 plus integer 1 plus integer 1, we can get it way down here. The nice thing is I'm going to show you a trick where we actually use Scala reflection to generate that code automatically instead of requiring you to write it by hand. Yeah. Yeah.
Where are we now at this slide? Where is the current state of the...
That's a good question. We are here.
Okay.
It's this one. So, and be clear, this is like this is like super handwritten as fast as you can make it. So I think the nice thing here is, other systems have CodeGen. This is actually a pretty popular thing. But I think our method of doing CodeGen is quite a bit simpler and therefore easier to expand. The entire CodeGen patch is less than 1,000 lines of code. And it does fairly general code generation for expression evaluation. And the reason is, we're making the Scala compiler do all of the hard work. So Scala has this pretty cool feature in 2.10 called reflection, where basically what you can do is you can actually take trees. What I'll do is I'll kind of show an example here. So what I want to do is I have some user has asked me to cast some generic expression to a string. And I want to generate bytecode that's going to do that. So the first thing I'm going to do is I'm going to get the result of evaluating this expression that we're going to cast to a string. So I just kind of recurse on myself and get that. And now I'm going to use this kind of really cool trick in Scala 2.10 called quasi-quotes. By starting this block of quotes with a Q, this is no longer a string. This is actually Scala code. And what I'm getting back from this is a Scala AST. And what Scala does is it will actually allow me to splice in values from other evaluations in here. That's what all of these dollar signs are. This is very similar to the string interpolation that also is added in 2.10. But you can actually splice in those trees, and Scala does all of the work of then figuring out the types and efficiently generating bytecode to do this evaluation. So that's kind of a really quick overview of the optimizer. I want to talk a little bit about the roadmap as well. So if you check out Spark Master, Spark SQL is there. We've already got some people using it. Sometime towards the end of April, as Andy said, today was the code freeze for the 1.0 branch. And once we QA that and cut a couple of release clients, or release candidates, this will be it will be an alpha component in Spark 1.0. And then there was the question earlier about Sharp. Very soon after that, we're going to be looking to provide a preview release of Sharp that lets those of you who kind of need the JDBC or these other Sharp interfaces to also kind of leverage the power of Spark SQL. And kind of our near-term focus here is to make this one of the fastest SQL systems available. So we're working on stability, compatibility, performance, and then also this integration with the Spark ecosystem. We want to make it very easy for you to work with all of the other cool things that Spark has, Spark Streaming, MLlib, GraphX, and also SQL, kind of all seamlessly. So that's kind of the end of this. I also have a demo which I'll do, but maybe I'll pause for questions beforehand if there's any more. Yes?
Is there any plan to support, so one thing that Spark is based on is immutable RDDs, the idea that RDDs is stable. But are there any thoughts to morph RDDs and let's go into kind of like an update of this?
I would say that's not on our immediate roadmap.
Michael.
Yes. Oh, sorry. The question was, Spark is based on immutable structures, RDDs, and is there anything on the roadmap where we would kind of handle more of the update workloads, maybe something more OLTP-like? And I would say that's not on the roadmap of the Spark execution engine, but what is the ability to interface with systems which already support that use case. So reading data from Cassandra, reading data from HBase, and running Spark SQL queries over that data. So I would say, in general, Spark is not well suited for lots of small updates, and that would require pretty major re-architecture of the system to support that. But I think we can leverage reading data from existing sources that already have that use case. Yes.
What is the catalyst optimizer performance compared to Shark, Hive,
So I'll say one thing. We haven't benchmarked the query code. What is the performance of the Catalyst optimizer compared to the Sharp or Hive optimizer? And first of all, I'll say I think that's actually the wrong metric. You don't care how fast your optimizer is, you care about how long the entire query takes to run. We spend a couple seconds longer optimizing the query, but cut minutes or hours off of your query. That's great. We haven't run that benchmark. I see no reason why it would be slower though. It's actually quite a bit simpler, and I think that actually will lead to faster code as well.
Okay, so if I use the Shark, the Hive module on the catalyst, it should be faster.
Okay. This is an alpha release. I'm not going to say that it will be faster for every query compared to Sharp. We have run some micro benchmarks where we've seen improved performance over Sharp. And the plan is to invest resources into this until it is competitive with the best SQL systems that exist. Yes?
Maybe you want to integrate with Yarn.
Integrate with Yarn?
Yeah.
I mean, so Spark SQL is kind of just this component that's part of the Spark assembly. So it should work with Yarn using the standard Yarn ways.
No, it doesn't work right now.
Well, Spark doesn't work with Yarn.
Well, it declared. You know, between declaration and actual production work is a big difference.
Well, so patches are welcome. Yeah, I think there's nothing in Spark SQL that makes it harder to support Yarn. So the existing Spark for Yarn will work. With Hive, it's a little bit more complicated because Hive has a bunch of dependencies that you cannot package in an Uber jar, which is going to take some work.
So I'm not sure what you meant by declare versus like I know a lot of use cases in production running Spark on Yarn. Sometimes the specific configurations might make it harder, but I think in general it works on Yarn.
Okay, thank you. But our experience is a little bit different. Maybe they are.
Yes?
I just have a fun question. How do you like working with Scala symbols? Do you find an editor who actually does not confuse them with strings?
That's a good question. So how do we like working with Scala symbols? Do people confuse them with strings? That's a great question. The API is out there. Let me know if you're confused by it, and we'll try and fix it. I have not been. Any other questions? So I was told that this wouldn't be a Spark talk if I didn't do a demo. So let's try this. So what I've done here is I've just opened up the Spark console, and I'm going to start by loading a file. So I'm going to take my Spark context, and I'm going to load a text file, and we'll load this people.text. Oh, JP, I'm warm up. So now that we have this file, you can see this is kind of just a standard RDD. We can see what's in there. We've got some interesting data items here, some people. And what we're going to do is we're going to apply a schema to this. So even from the REPL, I can just create a case class, person. And a person has a name, which is a string, and an age, which is an integer. And now I can, using standard Spark RDD stuff, convert this into a Schema RDD. So I'm going to split it by that comma. And then I'm actually going to create person objects. Person. And then I can grab the first column and the second column. Okay, so now I've got these people. And so you can see people is just a standard RDD at this point. But if I want to actually perform an operation on it, so let's say I say people where age is greater than 13. And so what you can see is this normal RDD was magically transformed into a Schema RDD. And what the Schema RDD is showing you is the actual plan. So we're taking this existing RDD, and then we're applying this filter that we talked about to it. I can actually kind of chain these operations, where so age is less than or equal to 19. And kind of one of the cool things you'll see here is we actually, you can see some optimization happening here. So I did two different filters, and those filters, using that rule that we showed earlier, were actually collapsed down onto a single filter. It's going to be much more efficient to evaluate. So that's kind of the power of optimization here. And then the really cool thing is now this is itself an RDD. So I can just call collect on it, and I actually get back the row of entries here. Since this is still a Schema RDD, I can also do people.as. And now I can run SQL queries on it. Does that work? Actually get the results, and there's all the people. And if you really like HiveQL for some reason, you can also do from people select star. Ta-da! Okay, so that's my demo. Thank you very much for listening.
Hold on, I want to make fun of
He's got some minutes.
just last few things. Yeah, I mentioned 1.0 is coming. So first, thanks, Michael. 1.0 is coming, and this is probably one of the most exciting features in it. In addition to this feature, I forgot to say some of the others. There's improvements to the ML lib. There's a persistent web UI, which anybody who's been a heavy user of Spark knows. When your Spark application goes away, or up until 1.0, it's hard to see the logs and standard out of your executors, for instance. The web UI is now persistent in 1.0. There's and Java 8 support. So Java 8 support brings with it a bunch more functional like operators, like closure, better closure syntax. So, and of course, as Michael just told you about Spark SQL and Catalyst. That's all in 1.0. So there's a bunch of momentum happening in the community around that. There's more momentum besides just 1.0. There's a bunch of projects. So Spark's kind of hitting a tipping point. You know, we have this awesome history of having bigger and bigger events. The summit that we planned in December was 450 people. The summit we're planning in December is 1,000 people. So, well, we're hoping it'll be 1,000 people because that's what we bought food for. Bring your friends. And besides that, the project itself is getting more users and more production use cases. So, of course, Cloudera announced that they support it. You know, the premier Hadoop distribution provider, Arun Murthy, this is now more rumor, but Arun, who wrote Yarn and is one of the lead engineers at Hortonworks, tweeted on the 3rd of this month that Spark was now in the Hortonworks HDP, so their data platform. I haven't seen the official announcement yet about it, but maybe we keep our eye on Hortonworks to see if they actually are officially supporting Spark yet. And of course, they have Tez, which is, you know, looks a lot like Spark if you cross your eyes a little. I want to say thanks again. In addition to like summits growing, people adopting the project, more meetups happening, we need to keep doing more meetups. So first, thanks to Tagged again for hosting us here for the second time. And with that, a request to you to host a meetup at your company. It's a great opportunity to stand in front of 100 people or 80 people or whatever's here tonight and give a spiel and say that you're hiring. It's also a great way to get more engaged with the people at the companies that are leading the way with Spark and to plug yourself into the community more. So come and talk to me if you can host meetups. Like I said, we're around 20 now and we're upping the rate at which we host them. And then more on a slightly more personal note for me, we need help with documentation in Spark. So if you're a heavy user and you at all had an experience of coming to Spark and finding that the way that we laid out the getting started guide and then the intro to the programming guide in Spark was, there's some bugs in it or it wasn't quite right, submit a pull request to the website or email me about it. We are constantly looking for people to help improve how approachable the project is. And there's a good chance that 60% of the people here tonight are pretty new to the project, so you're the perfect group who hasn't been staring at the code for the last 2 years or even 3 months to actually contribute something small back to the project. And what's your motivation? Well, Spark is quickly becoming one of the most active big data open source projects, so you can have huge impact. Like in the last month, the Spark Apache website had 130,000 unique page views. 25 of those were uniques. So that's a lot of documentation. People coming to revisit over and over to the website. We're close to like 2,000 uniques a day on the project website. And so every little piece of code that you contribute, or HTML or coding example, is going to be amortized pretty widely by people that are picking up the project and using it. And we think the project itself is on the way to becoming kind of the next Hadoop-sized phenomenon in open source, and it's got a lot of momentum so far. So if you're interested in doing that, we're desperately looking for people to continue refining and making the project just extremely easy to approach from a documentation perspective, or writing usage examples, or whatever you're interested in. The screencasts now, we did 4 screencasts. The first one has over 10,000 views on YouTube. So like, it took, you know, it's a 10-minute screencast. If you make one, you'll probably get, you know, a pretty good number of views yourself. So I just want to, you know, put that out there. That's how we work as a community, and that's kind of the Berkeley roots of everything as well. So thanks for coming in tonight. Thanks again to Tagged. Let me know if you can host a meetup of your own, and we'll see you at Cisco for the next meetup.